We have gone over a lot of exponent rules, so we are going to review over them. If we look at the multiplication properties of exponents, you see that we have like bases being multiplied, we will add our exponents. If we have a base that has an exponent and it's being raised to an exponent, we will multiply exponents. Then if we have multiple terms inside the parentheses, we're going to send that exponent inside, which it kind of reminds me of distributing. So we're going to send the exponent to each term on the inside. So let's look at our other rules. So quotient rule, quotient of powers. We have a to the m over a to the p. If we have like bases, we will subtract the exponents. Zero exponent, anything raised to the 0 power equals 1. So like x to the 5th over x to the 5th, if you subtract them, you get x to the 0, which gives us 1. We could also just cancel them out, simplify them out, and we get 1. Then the negative exponent, anytime you have a negative exponent, you're going to switch the location of it. So if it's on top, you're going to put it as the denominator and change the exponent to a positive. If it's on the bottom denominator, you're going to put it to the top and change the exponent to positive. So let's look at our newest rule, which is called power of a quotient. So for this one, it's saying we have a fraction inside a parentheses and an exponent outside. What we are going to do is we are going to send that exponent to every term on the inside. So this becomes a to the m over b to the m. So let's look at our first example. We're going to send this squared inside. So we're going to send this to the 3, and let's go ahead and write what our new number is. So that would be 3 squared. We can write out 3 squared and then simplify it, or we can just do 3 squared, which we know is 9. And then send our squared to the P3. We're going to multiply our exponents, so that would be P6. And then send our squared to the 7, which would make that 49. The last thing we would do is just check and see. We just need to check and make sure that we can't simplify the numbers. So if I look, I'm going to put it in the calculator and just make sure it can't be simplified. So put it in as a fraction without our variable, just the numbers only. So alpha y equals 9 over 49. If you put it in as a fraction, it's going to simplify it as a fraction if it can be simplified. Don't just put 9 over 49. That's going to give you a decimal. We want it to stay as a fraction. It comes out the same thing, so we cannot simplify it. So we leave it just like that. And then our p to the 6, there's nothing else that can be combined with it. So this is just our answer. All right, so let's look at the numbers on, or the problems on the inside. We'll start with number 1. So this is to the 3rd power. So we're going to send it in and go ahead and find out what is 2 to the 3rd power. Nope. 8. It means 2 times 2 is 4. 4 times 2 is 8. So 8's on top. And then a squared to the 3rd. A6. And then B has a 3rd power, so now it's B3 over just A.
Did we not add 3 to the A on the bottom? Yeah.
Yes. Good catch. Good job. So now we look and see if we can simplify it. The 8 has nothing to simplify with, so it's just 8. But the A's, we have A6 and A3. So we're going to subtract those. So 6 minus 3, 3. And then B has nothing like it, so it would be B3. Nothing's on bottom, so I don't need a fraction, so I'm actually going to make that into a box around it. Let's go to the next one. We're going to send this 3 to the 4, so it's 4 to the 3rd power. Let's go ahead and find out what that is. 64, good. So this will be 64. Send it inside here. P to the 4th to the 3rd. We're going to multiply those. P12. Then send this in. So it'll be R12. Now we need to do the same thing to the denominator. Send the 3 into the denominator. So 3 to the 3rd power. Send 3 to the P squared. Send 3 to the R squared. Then see if you can simplify your fraction. So put your fraction in the calculator. So 64 and 27 don't change. So then let's look at our like terms, our like basis. So P12 and P6. Subtract them. So that's P6. R12 and R6. R6. And that is all we can do. Okay, go ahead and do the next one on your own. All right, so let's see how you did. 2 to the 4th power. Is it 16? 2 times 2 is 4, times 2 is 8, times 2 is 16. Send the 4 to the R. R20. Send the 4 to the 3. 12. Send the 4 to the R4. Send the 4 to the 3. Right away, I see I have common W's, right? So we can go ahead and mark those out. And so then we're just left with 16. Now look at your R. R20 over R16. We subtract them. R4. And it's complete. There's nothing left on the bottom. Go ahead and do the next one. So I'm going to go ahead and do it. 3 to the 4th is 81. Then send the 4 to the R6. So 4 times 6 is 24. So R24. And then to the N3, making that N12. And then raise the 2 to the 4th, which we did that earlier. 2 times 2 times 2 times 2 is 16. And then send the 4 here, R5 to the 4th, so R20, N to the 4th. See if we can reduce our numbers. Let's put it in as a fraction. 81 over 16. Nope, can't be done. So we'll just continue to have 81 over 16. And then look at our R's. R24 and R20. R4. N12 and N4. And that's all we can do. We do have a couple of problems on the bottom that we have not finished. So let's look at those. Just to review, number 6. I'm going to work it out a different way than we worked it out before. But I want you to see that it's the same thing. So a squared b cubed to the 2nd is still a squared b6. But whenever you have a negative exponent, just go ahead and take it up to the top and change the exponent to a positive. So it'd be like that.
How is the first one a squared? Because it's 2 times 2.
Oh, it's A4. So then we would need to send in the square to everything. So this is still A4, B6, A squared, B squared. And then you would do your A4 and A2, which makes A6, and B6 and B2, which makes B8. So there are actually 2 different ways to work this out. I would say get rid of the negative exponent first. So this second way is actually the preferred way. Okay, let's go to number 9. So let's deal with the first thing that we see. 3r2 raised to the second power.
Right time.
Sorry about the fire alarm. Let's go ahead and go to the next problem. We have 3r2 rt squared. So we're going to distribute. So 3 squared is 9. R squared. T squared. And then this u to the negative 4, we need to put that on bottom right away. So it'll be u to the 4th on bottom. And then we have t squared, nothing we can do there. U7, nothing we can do there.
We gotta move that negative R1 up.
Yep, so then we just have r, right? Good, got it. All right, so now we see that we can simplify. If you have the same thing on top and bottom, simplify them out. We have no t's left. So on top we have 9, and then we have r squared and r. R3. And then u to the 4 and u to the 7. To the 11, yep. And that is it on that one. All right, let's go to the next one. We have m to the negative 3. So we need to put that on the bottom as m3. T to the negative 3. Put that on bottom, t3. And then this whole thing is raised to the negative 1. It all goes on top.
So everything's flipped.
Yeah, everything is actually flipped, exactly. So this is to the negative 1, so it'll be to the positive 1, but just an exponent of positive 1 won't change any of our variables. So we're going to leave it the exact same. We have t cubed. It's going to simplify out. We'll have no t's. And we have m squared over m3.
So it equals m.
M to the negative 1. Because when you subtract, you have m to the 2 minus 3. That gives you m to the negative 1. What do we do with negative exponents? Yep. M to the first power, or just m. And then if there's nothing on top, put a 1 on there. The next one, the easiest one in the whole thing. It's raised to a 0 power. What does that mean?
0.
Equals 1. Anything to the 0 power equals 1. Yeah, that's like an L or something. But it doesn't matter because it's all raised to the 0 power. Everything inside of this turns to a 1. Okay, the last problem. Negative 2 m n squared raised to the negative 3. Yep, it's going to go on bottom. So it's going to be negative 2. Oh, I need to keep in parentheses. M n squared to the 3rd power. Four is going to stay on bottom. So we dealt with the negative there. We need to deal with this negative exponent. So that's going to go on top. M to the positive 6. And then n to the 4 just stays on bottom. Ooh, we had to scrunch that in there.
Wait, that's been on the bottom.
It stays negative 2 m n squared to the 3rd power. We keep it inside the parentheses. The only thing we changed was taking it to the bottom and changing the exponent to a positive. All right. So now we need to send in this 3rd power. So anytime you have a negative base, you've got to keep it in parentheses. So it's like, let me zoom out a little bit. Negative 2 raised to the third power, which is -8. So we still have m6, and then that's -8. And then take it into the m. So it'd be m to the third power.
Shouldn't we move that 8 up though?
Nope, because it's a -8. It's not an
Oh.
8 to the negative power.
Oh, okay.
And then n, send it in, so it's n to the 6. And then we still have times 4n to the 4th. All right, we still got to keep on going. So I'm going to go ahead and multiply -8 times a +4, because you need to combine your like terms by multiplying it.
-32.
-32. And then we have m6 over m3.
And to the second.
Mm-mm.
Oh,
Subtract them.
And the cube.
M to the third. And then n6 and n4.
And the
10. Okay,
that was way too
that's it. So your assignment is on Delta Math. There are 12 problems this time. Make sure to show your work.